Ready? Go. That's what we have. So we were talking before about humans and programming and AI and biology, and so I think we'll jump into some easier subjects for the start of the video at least.
Yeah, yes, please.
Tell me a little bit about you,
Yeah,
because
sure.
your background, because we met not too long ago in Norrköping when I was pretty new to the city.
Yeah.
And you were I think on LinkedIn or Facebook.
Yeah,
or
it was LinkedIn. I think it was the LinkedIn group.
yeah
Actually.
yeah so you just asked for some company,
Yeah.
someone to join for like a walk or whatever.
Yeah.
And I was like, let's go.
Yeah.
And from there we've had like,
That's what you were doing during that time, from my understanding.
yeah I didn't do anything else. I was just hanging out with people, trying to get used to the city and the people in it.
Yeah.
And I remember we were getting to know each other, and then you told me you're a programmer, and we talked a little bit, and now you're actually helping me with a project.
Yeah.
So we'll get into that soon after your presentation.
Okay.
Tell me a little bit.
Yeah.
Tell the people.
All right. Yeah, well, I don't have a whiteboard, so it's going to be a little bit difficult. But so I'm from Czech Republic. I grew up there, lived there, studied there, and then I started working there. And then maybe 5 years ago, with my wife, we wanted to try living abroad. And then we kind of traveled a bit Nordics, so we liked the space here. And then I applied for a few positions and got an offer from Klarna in Stockholm. So we moved there. We've been there for 2 years, I think. And then we moved down here to Norrköping, which is like much friendlier, smaller town.
Yeah.
At least for me. I like smaller towns than Stockholm.
Are you from a smaller town? to
I
begin with?
am. So it's a small village actually. It's maybe, I don't know, 500 people living there, maybe a little bit more. But it's like adjacent to a town, so something like Åby here in Norrköping, I would say.
Yeah. I think we should stop doing the things between the
Yeah.
surface and because I think the microphones will
pick it up.
a lot.
Sure. Here. Yeah. So
Now you're here?
now I'm here. So I worked a little bit for the Norrköping Tidningskar, the newspaper company here in town.
Ah, I didn't know that.
Yeah. I think I was there. It was probably less than a year. That was like a first gig. It's really friendly people there.
Mm.
It was fun.
And what did you do there?
Well, as a software engineer.
Yeah.
So they have a.
So as a software engineer, what do you do in...
Yeah. So one of the tasks I remember I was working on was that they were rebuilding the web design of the newspaper.
Yeah.
And this company, the NTM, they own a lot of different local newspaper across the whole Sweden. So you would build it once, like the website design thing,
Yeah.
and how it works, and then you would reuse it for every like local newspaper.
Yeah.
So one thing that I remember I was working on was just notifications, both for the phone and for like the web client. So if you open on your phone the thing in a browser, you still have an option to do like a notification there, even if it's not an application actually.
Mm-hmm.
And same goes on your laptop. You might have seen that, like sometimes things do pop up even if you're not on that site. It can pop you up in like different places. So there are notifications on
Sounds
the browser.
like the kind of things when you go into a porn page, man.
Yeah, possibly. No, but it's quite often like when you do like a chatbot
Yeah.
with Bauhaus or I don't know, some company,
Yeah.
and they have a chat, and you have an option to say, please notify me, and then it can notify you even after you close the page or you went somewhere else.
Because that's one thing that I'm not really big into programming, or I haven't really got it into it that much.
Yeah.
It's not my field of expertise, but I always like learning new stuff, and because we're doing this project together, right?
Yeah.
We're doing the umbrella bostadsrättsledning,
Yeah.
and you were helping us out with the portal. So we have like the main homepage,
Yeah.
which I did most of the things in Elementor
In WordPress.
in WordPress, and from there you can go to the login, and there you can go into the portal, basically like an web app,
Yeah.
like a web app. And when we were doing that, I didn't really understand that it's way different to do an application in the phone or for your Mac or whatever than it is to just build a homepage. I was thinking that it's basically the same language. It's basically like the same everything. What is the big difference like between building a homepage, like just the way it's programmed, and then from there to convert it into an app?
Yeah. So I haven't done too much apps, so I might not be the best person to answer this, but I will try to do as well as I can.
It's probably better than better than the information I have already.
Yeah. So there are like lots of different technologies you can use to build stuff online, and some of the stuff that you build isn't even web page. It's just some APIs that do something. Like you could imagine, there could be an API that you wanna, I don't know, send some item that you're selling. You can send some API call somewhere to find out how much CO2 was probably generated to create this item.
And what is API? Like already there it's...
Oh yeah, sorry. So API is an acronym. I think it stands for application interface, something.
Okay.
But it basically way for computers to talk to another computer.
Okay.
So like
So for a normal person to understand it, it's is it like the language they use or the technology they use, or?
This is just a very general term. So something like you would use language in between people.
Yeah.
You would say API in between computers, maybe.
Okay, so if you have different APIs, then they can't understand each other, just the way that people can understand different languages.
Yeah. I mean, there are different types of APIs you can build, and then they don't understand. But it's also you need to be very specific. So you need to implement the actual API of that site. So if I would, the example I came up with, the CO2 emission provider, so it would be a company that doesn't have any website for people to use. You would, as another company, like sign up with them, and then just your website of the second company B that purchase the service from the emission company.
Company A.
Company A, would send a request on the background, and nobody would see them except of those two computers, those two websites, let's say.
As long as they have the same APIs.
Yeah, you would have to implement. So the company B would have to implement the API of company A. So it's like you have like a levers and LED lamps, let's say, like
levers,
signals. Like a lever is a thing you can pull, or like a button.
Oh yeah.
Like
so
physical button.
brytare in Swedish.
Yeah, I guess.
The way that you turn on and turn off your lamps.
Yeah.
Yeah.
And
switch.
So company B needs to kind of know which buttons to press and on which lamps to look at to get the information they want.
Matt, you're losing me. You're losing me, Matt.
Okay.
What the hell? So, but basically, so APIs are the language of the programs, like the interfaces. Doesn't have to be computers, can be whatever technology. But just if they need to, if they have to communicate and share information in some way, it needs to be an API, and it needs to be the same API. So the best way of doing that, I guess, is to have some kind of general API. So the way that they have different languages. Now we're speaking English because English is like a general language that both of us understand. Yeah. So that's probably like, because I've heard the term open API. Is that basically what that is? Just like an open language that most of them understand?
Open API, from my understanding, is just that it's you don't need permission from that company, let's say, to look at their API, to use it. While in other cases, like more common case is, I guess, you would it like sort of special username and password, let's say.
So it's not about the language,
No.
it's about the accessibility.
Yeah, exactly.
Okay,
That's a
so
good point,
that
yeah.
it's not locked, basically.
Yeah.
Okay, so back to, then we understand basically what an API is. So back
Yeah.
to the usage of APIs in the difference between
yeah,
apps and.
yeah, I was saying, yeah, that was a kind of side step.
No, I needed it because I
Yeah.
didn't understand what it was.
So a lot of what things are on the internet are not client facing, let's say. So there isn't an app, nor web application, nor mobile app. That's what I was trying to get to. So you have a lot of like processing work happening on the back end, and then only the part that you see, what's the website or the mobile application,
The front end part of it.
the front end part of it exactly is sometimes quite small part of what's happening here.
Yeah. And that's also one thing that I had to learn through our process together.
yeah.
That you're like, yeah, I did 70% of the work. I was like, yeah, but it looks like shit.
Yeah. Well, that's
And then,
that's another problem with my design skills, which
Yeah.
are non-existent. But
Yeah, but I didn't understand how much had to be done in the background for just some simple functions in my
Yeah.
to my understanding to even work.
yeah, because you have like
Just have to log in. And then you're like, yeah, but log in. You need to find the information for somewhere. You need to have.
exactly, you need to store user data, like the username password in some way. Then you want to be secure, so you don't want to store the password as is. You want to like kind of different ways to do this to make it secure, and then you need to like take care of that. And then whatever you want to do, like you need to kind of store data about what's happening. So let's say you would like to, I don't know, send message to somebody. You need to take this message and store it somewhere so that the other person can read it.
Yeah.
And so there's a lot of.
But
things.
but when you have the back end part
Mhm.
covered,
Yeah.
is it really different from between an app and a web page?
Well, there are different designs you can do this. You could, like the one of the older approaches, I guess you would say now, is that you would have that combined. So you would have the same application that does all the backend work. That would also serve you the front end in a way that it would provide the website.
Yeah.
And then it's kind of hard to jag in like an application or some other interface you would
Yeah.
like.
So what you're saying basically that nowadays there are web page or applications or tools at least that give you like a package. So they give you package solutions and different modules or whatever that you put in.
Yeah.
And if you build something that way,
Yeah.
like with the modules, the way I built our homepage,
Yeah.
then it's hard to like separate it and do something different with it.
Yeah, because then like the front end, like if you build it all together, the web page, the front end could have like a kind of shortcuts to get to the data, and then you cannot use the same shortcuts when you have a mobile app. But the more modern way of doing this is that you would like kind of build the backend logic separate from the front end, and
Yeah.
then would expose these APIs that we talked about, like this common language,
And connect them through those.
and connect them through those. And then it doesn't matter what the client is. It could be your phone, can be like your browser.
So basically, if you build the backend in a way that is suitable for different clients,
Yeah.
then you should you should be able to just mirror it to the different clients through the APIs.
Yeah. And then
Yeah, we're getting close to.
and then you're
Okay.
not limited to like web or mobile. You can hook up another server in front of it, so you could have another company using your portal or your
Yeah.
tool.
Yeah.
And
Through mirroring. So
yeah,
basically, they copy paste your functions and put it into their.
not copy paste. They would use your functions. They would call your backend, but then they would do something else maybe, or display it in a different way.
So you mean basically that what they're doing? So basically, it's like cars. So cars, they have the same, maybe the same what's the English name? Okay, so maybe it's the same engines, right? Or the same transmission boxes or whatever.
Yeah.
They have the functionality, everything is the basics, but then they change like the looks and then they change some different parts of it, like
Yeah.
design parts. Then you have like a different car,
Yeah.
a new model, but it's the same
Yeah.
basic functions,
Kinda.
and you just tweak it a bit.
Because one good example of this is that, say you have a really good, I don't know, finance app. It does something cool, and then you use it. But then some bank wants to have that same capability as you already have.
Yeah,
So what the bank can do, they can pay you for the service,
for the functionality.
and then in their own website create a section that would just use your backend.
Yeah,
So they will ignore whatever you've done on the front end,
the design part. Yeah.
and then build it again, but using the APIs, they can reuse the backend and pay you for it.
And are there? Now we're getting into really interesting things, because now we're getting into businesses and business ways of doing business. That has to be like a pretty big market, right? And is there like any? I'm thinking that probably Google or Facebook and all those, they have most of their same. It's their own things, right?
Yeah,
they're doing their own things. They're building their own.
Yeah,
they're programming all the backend themselves. But
Yeah.
are there companies that are doing a lot of money just building backend stuff and basically renting it out?
Yeah, one example is Ting here in Sweden. What they do,
Ting.
Ting, I think it's called.
Yeah.
What they do is they aggregate your finance data. So they take data from different banks,
Okay.
pull them all together, and then you could use this aggregated data in whatever you say. You want to build a budgeting app that will help people budget, and then they could use this thing to like pull in on your data no matter what bank you're using.
Yeah.
And then this thing business, they don't have, or they do have like a demonstration application, but maybe even more. But their main business is that they will sell you this functionality. And you can build your own.
So basically, if you want to build an app, you want to build something that has functionality of grabbing the information from different places, aggregate it into one place, and then use it in some kind of way.
Yeah.
Doesn't matter if it's they want to do some chart diagrams, statistics, or if they have some business model that uses the information. They can just grab the through API, have a connection with the backend from Ting, give them some money, and then they have like half of the app already, and then they just build on top of that.
Yeah, you could say that. Yes.
Yeah, that's interesting.
Mm-hmm. And then a lot of the big players nowadays, like the Google's, AWS, they are starting to provide services that are higher and higher abstraction. What we say, it basically means it does more stuff with less coding.
How does that work?
So they would provide you maybe AI network that you use, and you just say, I want to look for, I don't know, bags in the pictures, or like cars in the pictures, and then you just send in the pictures, and it will tell you there is a car or there isn't a car, and you could use the service already without without coding it, without knowing anything about AI or knowing.
So basically, there is the code, like you always need the code, but they package the code into like a small string of information which you can insert into your code, which makes it a bit lighter.
No, you would use API in this case again.
Okay, so you wouldn't even have their code.
You wouldn't have their code, no.
So you would just transfer the information or their functionality to your and is that something you put into the code, the APIs?
You would use like they usually have like again, it's called client. Which is just that it knows how to communicate with that specific thing that you want to connect to, and then you would just in your code call, say, I don't know, picture verify or something. You would just call a method or like a function or let's call it like it's interface. I would say. Yeah. And then you get result immediately, but you don't need to think about how that all happens because they've done that.
Yeah, they have the functionality in house. I understand.
And they have a bunch of different stuff. Like even in the portal we talked about, what we're using is Firebase from Google, and they've built it in a way that you don't need to think too much about the backend. That you could kind of limit it in a way that you just have APIs to get data, to store data, and you don't need to build too much, like, because you need to kind of figure out a security layer. That's one of the important things that
Yeah,
you want to do.
I think that's one of the most crucial things.
Yeah,
Like, and also one of the things that destroys
Yeah.
everything every time.
yeah,
At least from my understanding and from like a logical point of view, usually like when you start to build up functionality and you code functionality, and then you're like at the end and you're like, yeah, that we have the functionality, that's nice. And then when you add like when you need to look at like the security part of it, you understand that half of the things that you have programmed are gonna have to go through different layers of security, and therefore much of the much of the functionality that you have coded is already unusable or has to be changed in order to go through and sift through those layers.
yeah,
And not only that, because when you have done that and you're done and you're good and you have gone through all the hoops, then in half a year new information and new security measures get into place, and then you need to rearrange everything that you have done basically, or big parts of the code.
Yeah, more common than like a new security threat coming in is that you just develop your app somewhere and you add some new features, and suddenly you introduce by mistake some way to like read data that you were not supposed to read or something.
Yeah.
Like say, like one common attack is that if you expose your IDs, like identifiers of some item, let's say you order stuff online, like food,
Yeah.
and then you get some ID, and if it's 12 in your URL in the the browser on the way top, and you change it to 13 or something, and you still get to see some data from some other order that you didn't place, that's one of the common vulnerabilities, because they are not checking your identity properly. In that case.
Yes, you can basically go into other orders.
Yeah.
Because the only way they're identifying the orders is like this string of text
Yeah.
plus 11, 12, 13, 14,
Yeah.
15, 16. So those are the different
Yeah.
people or customers or orders that are going to, and by changing them, you can basically loop into someone else's site.
That
and
is
I saw something about this, like it's like a TikTok hack. It's not that I'm that much on TikTok, but actually, do you know who Linus? It's like a big tech guy on YouTube, Linus something. So he's putting up like everything gaming, everything techie, everything whatever. A lot of computers and programs and whatever. And he was going through like some TikTok hacks, which are not hacks, but are some like interesting features that you can do, just understanding some easy functionality of the internet. And I think there you could go to some page and you can just change, put in some random text, and in the end of the URL, and basically whatever you put in, you would get some new information or a new picture. And basically what that was just a database from somewhere where you have uploaded your picture to edit it, or to upload it to like some data. So whenever you upload a picture to Facebook or Instagram or whatever homepage it might be, of course you're basically giving away the picture. Like you're saying, this is my picture, but you can have it. You got the rights for it in the internet, but I can use it the way I want to use it. And therefore they need to store it somewhere. And most of the time those are really secure servers with Facebook and Google and whatever, so you cannot just penetrate them and find the picture like that easily. But some of these don't really have that functionality and the security, so that you can, the way you said, just put one URL and just put in a random number or random sentence or whatever, and then that would just be a combination that refers to one of those random pictures. So I saw he was doing like, sometimes he got like a selfie, or sometimes it was just a picture of a dog or whatever. That's crazy.
Yeah, so more than like a new security threat, there are these every year they are collected to like good practices or like common security threats that you need to look out for. It's called OWASP top 10 usually vulnerabilities, and then each year they kind of update which were most like exploited things so to look after, and which are and how to like basically combat them, so like how to secure them, because in proper application if you change the ID you should get something like you don't have permission to view this. So and there usually are several layers on which you should check this, so that even if you like forget or it doesn't work on one layer, you will still have like a backup layers where this works. And even when we were talking about like these pictures and how they store them secure way, 99% or like quite often they are encrypted even. So even if you would like get access to the actual server, took the hard drive out, you don't not get to see the picture.
Because you don't have the key to encrypt it.
Yeah, to decrypt it, yeah.
Yeah.
You don't have that key. And then it may be even easier to like use their application if they have like application level hole somewhere that you can use, like changing this ID, and then the application will decode or decrypt the image for you and show it to you because it's like badly written.
Yeah, because it's easy. It's an easy code to crack, like easy key to replicate, basically.
No, it's not about complexity of the key, but it's just that they haven't covered this. They haven't checked that you're authorized to see the picture or not, and then they would use the key to like show it to you.
Okay, so it's a bad key, basically.
It's a bad
code. It's a bad code. It's a bad lock.
Application.
A bad lock.
Yeah, maybe. Yeah.
So because an encryption is a lock, basically, just like a box around the real code.
You can imagine it that way.
Yeah. And then when you have the key to decrypt it, that's the key to open the box and you see what's inside.
Yeah.
And otherwise it's just like some mumbo jumbo, something that is random or not correct or.
Yeah.
That's the most because I was using like encryptions when I was younger usually, and the most confusing thing about encryptions is when they're similar to something that you would anticipate to see.
Oh, like
but they're not that
version.
Yeah,
I see.
So like the real thing is maybe like a picture of a girl, and the decrypted version is a picture of another girl, but a random girl, so not the girl that
well, that must be really weird.
That's really weird, because then you think that you're in, but you're not really in. Or like a picture of a dog, they're like, oh yeah, that's what's inside, and then you don't think about it anymore.
Most likely that was just their application level thing, like they if you don't have the authorization they would show you some other picture, because it's very unlikely that you would like encode an image and it would still make sense for us humans, because it's just gonna be like a random.
Another thing that I was thinking about, when we go into hacking and we're talking about like encryption and decryption and because nowadays it's really popular with like bitcoins. Like the last 10 years, it's five, maybe not 10 years, but like 5 years. Okay, it's been a boom. Before that, also it like Bitcoin existed, and it was just more like an underground thing. But nowadays it's been more with the crypto, and then after that we've had like the thing I showed you, like the BitClouds, where you could with crypto basically create your own profile and your own NFT coin.
Representing your person.
So basically, like if I would have like a NFT, which is a non-fungible object, right? Token. So an NFT, for those who don't understand it or haven't heard the term, it's basically something which is not interchangeable.
Exactly.
So if you have like a dollar bill, you can change it to another dollar bill. It's still worth the same. It's still the same thing. But for example, if you have like a signed shoe from Michael Jackson, then that is like a really special thing, and you cannot change that for another shoe with another signature or another shoe with his signature, because it's not the same shoe. So it's like an ID number of a thing that you can own, and this thing can be like whatever. I just heard on a podcast, the Joe Rogan podcast, that there was one episode when Joe Rogan and Elon Musk was smoking weed.
Yeah.
Yeah, and someone has made a NFT token out of that
Moment.
that moment.
Yeah.
And is now owning that, and was selling, and someone else bought it for like $5 million.
Yeah. Yeah, the weird thing about this though is that
and why I came into this is because I just want to end the circle because I want to talk about this, but because I'm really interested in it. I think there is something there for the future.
Yeah.
And I really think that usually we always say, oh yeah, it's not gonna be shit, it's not gonna happen, it's crazy, we don't understand it. But that's the same with internet, and that's the same with crypto, that's the same with mathematics once. I mean, basically it's just mumbo jumbo until it's real. But I was thinking, since it's digital, and since we're talking about hacking or encryption and decryption, like that much money, wouldn't it be easy to hack it? And because I think that's one of the worries. That okay, it's just code. It's just code.
So how this works is like there are a bunch of different blockchain technologies out there. Blockchain is more general term for like cryptocurrency. Is one example of blockchain.
So blockchain is basically the functionality, the technology, and you could just give
summarize,
us summarize the quick version of blockchain.
So the blockchain itself, the idea there is that you have like a chain of blocks, and each block is just like a box into which you put transactions that happen. So let's say I send money to you. You send money to me or to somebody else.
Yeah.
And you put these transactions in a box, and then you kind of, well, it's a compute hash, but what that mean is that you create a unique number based on the content of the box.
Yeah.
And it's one-way function. So when you have the number, you cannot figure out what was the content. But if you have the content, you always get the same number. If you have the same content, you always get the same number. And it's really, it's cryptographic function. So it will turn that content into a number. And then you do another block in the chain, and that chain needs to use not only the content, but also the number from the previous block that you computed.
So it builds on top of each other.
So it kind of links into each other.
Yeah.
That's where the chain comes from. Yeah. Because then if you would just like replace the block with something you want, like send all money to me transaction,
it would break the chain.
It would no longer compute to the same number.
Yeah.
And that would mean that the following block would have a different number.
So
it would be broken.
So if I just try an analogy that many will understand.
Yeah.
If you ever work with Excel.
Yeah.
So Excel is basically boxes, right? Cells.
Yeah.
And when you have functions between the cells, then they interact with each other. So for example, you have 3 plus 5, and then you have equals, and you have a summarize option which takes 3 plus 5 and puts 8, right?
Yeah.
So this is basically, in my head, blockchain, like the easy version. So you have something that you put into the like whatever, it's a transaction, or if it's a NFT, or it's you basically give it an ID number. The ID number will always be the same for that thing, but when someone else looks at the number, they will never understand what is the number. What does it stand for?
I guess it's similar.
I mean this is just trying to make it understandable.
Yeah, I know.
And then if you have the cells, and then you have the functionality, so summarize these two to each other, to this, and then you take this number and you put it into another function, which is maybe add together with this one here and divide by these ones, and you have a couple of functions on top of each other that relate to the same basic data. If you change any one of those datas to like a letter, then the whole chain will break. The whole chain will be like error, cannot compute.
Yeah.
Of course, in Excel, if you change it to another number, it will still compute it. So that's not how it works.
Yeah.
So basically, it's that fragile that it has to be exactly that number and nothing else. Then it will be an error in all of the.
That's a
something like that.
Something like that.
Okay.
Like on every step, it kind of makes sure that the previous step is correct.
It's correct, yeah.
And stores that information so that the next step can always verify that this is the exact step in a really short time. So that's the important part. You can verify that the block in the chain is correct in like instant time. Like it takes no time at all.
Yeah.
To figure that out. So you don't need to look into all the history that all the accounts like match.
No, but it's just n+1.
Yeah.
Like the last one plus this one.
Yeah.
Or a+1.
Yeah.
Basically. So it goes into the last one and this one. And it relies on the fact that the last time this was done, it was also okay. It was correct.
Yeah.
So each sequence is only for the last one and this one, but after 10 sequences that are separately, like can be years between each other, it just understand like it was okay before, it's okay now.
Yes. And then we have a thing called like full node and shallow node, or like partial node, and the difference there is that the full node.
What are those?
So that those would be, I mean, maybe that might be too detailed, but
let's try it.
In blockchain you have computers that are called miners, or like a role mining for the cryptos, it says. But what they really do is that they make sure that the transaction happen, that they do some change, and what they also do is to compute and verify that the previous transaction was correct and the one that they put in is correct as well. And then there is like kind of random logic in each cryptocurrency or blockchain. It's different, but it picks whoever's gonna put the next block in it and who's gonna verify the previous one. So then you don't get to cheat, because otherwise somebody else after you will figure it out that you cheated and your block will not be accepted by the other people. Because there's also like
so it's like everyone is spying on each other or verifying each other's activities.
Yeah, because you get like a reward if your block was chosen to be put into a chain, like a little bit of cryptocurrency in this case, and then so you want to do that.
So basically what you're saying is the mining that everyone has heard about, everyone knows that, or many people have heard about mining. And mining is basically a computer going around the clock, just looking the way that for someone like me who doesn't really understand it, I'm thinking that it just goes through information and finds small parts of cryptocurrency.
So what they're trying to do is, I want to send money to you. So that means that somebody needs to like decrease my account and increase your account by that amount. And in normal banking system, that would be your bank doing that. But here you need it's decentralized, so there isn't any central database where we hold this.
So someone else would have to do it, but it couldn't be you and me because we're inside the transaction. So someone else, random person, would look at this transaction and say, yeah, this looks good.
But then you need incentive for that person to do it, because otherwise who would do that? So then you have a mining thing where they get a small reward and you pay a small fee for the transaction and they get the small part of it.
Okay, so basically if we try to I mean, this is really interesting. I'm actually for the first time understanding this a bit better.
Okay.
Cool. I'm just learning here as we go.
But it's a really complicated topic, so
but that's good. That's why we're trying to take it down to like a level which is understandable even for someone who's not like into the topic. So the way I understand it now, if I try to just summarize, so you and me, we have a transaction. So I buy something from you. I buy some eggs, whatever. But I will pay with cryptocurrency. So you will get 1 Ethereum coin from me. I mean, that's probably not
way too
that's way too much. Expensive eggs.
Well, it depends on the egg.
Yeah, maybe it's golden egg. But you get 1 Ethereum from me, okay? And usually, if I would do this in normal money, I would just say to my bank, okay, so transfer from my account 1 coin and put in his account 1 coin, and they would probably not get any money from it. They will get money otherwise. They have some other ways of getting their money. So they have their incentives
Incentives, yeah.
in other ways. So
Yeah.
since we don't have the bank, Carl on the other side of the fence, who doesn't know us, have never seen us, don't know who we are,
Yeah.
he needs to do this.
Yeah.
But he doesn't do it himself, but his computer will do it for him. And the way it goes is that when you build this mining station, which is basically a computer with a lot of processing power, you just sift through random people's transactions.
Yeah, it's a little bit different. The thing is that there are different ways to do this. Bitcoin and Ethereum at this moment as well, they are using proof of work concept, and which is one way of doing this, like to verify, to basically choosing somebody who's going to do the next, to choosing the Carl to do this. But the proof of work, how it works is that you take all the numbers, like the transactions, compute some sort of number from it. That's not important too much how to do that, but then you add secret souls, like you need to guess a number.
Yeah.
And then with that number, if you add it up with all the numbers before that, like all the transactions. So let's say I'm transferring 100 crowns.
Yeah.
And that the number always needs to be 1,000.
Okay.
So he needs to guess 900.
Yeah.
But the way how is this set up is that you cannot like subtract from the target the amount that you're missing. So you cannot do 1,000 minus 100.
Yeah.
But you need to guess the 900.
Guess. And
and
there will be a lot of computers trying to guess the right.
And only then you will find out if you're correct or not. After you've guessed. So then what they do is that they will go like, let's try 100 plus 1. Is that 1,000? No. So let's try 2, 100 plus 2, and so on.
But that's one mining station doing that. But there will probably be other mining stations trying the same thing on the same transaction at the same time.
And the one who like wins, the first,
he will check the transaction, so the transaction will go through. Because of he's guessing correct. And by doing that, he will receive a small token, like maybe 0.01 points of Ethereum coin. So that's his basically that's his value that he gets for allowing the transaction or guessing correct, so that the transaction can go through.
And then one implication of this is that the more the value of the fee is, the more people will try to do it, the more expensive computers they will buy. And that also means that there will be more competition about guessing this number, and you need more and more processing power. So that's what
I had a nice idea about this, a business idea, not even understanding the concept, but I just understood that it's not taking a lot of space, like one of these like mining stations. It can be pretty small, like 2 or 3 computers big, and if you could build it like furniture or something that looks pretty nice aesthetically, you could sell it as a mining station, but also as a home appliance,
like a heater, probably.
Like a heater,
because a lot of heat.
because you could probably use it as a heater in the winter. That's nice. That's a good idea. Then you could have the cooling system just going on in the summer. I mean,
the thing is that because the price of these cryptocurrencies raised up a lot recently, the amount of power you need it's about statistics. Like you're trying to increase your statistic of guessing the number correctly. You want to be able to do as many guesses a second as possible before the other person guesses.
Because if you can do more guesses, you raise your, as you say, you raise the possibility of you guessing correct.
Exactly.
The probability.
And also the protocols, like a Bitcoin protocol, they have this kind of logic in it, and they understand how many people are guessing and how many guesses are being like included. And if that number raises, like the number of guesses being included, the algorithm will increase the difficulty. So it will say you no longer need to guess to 1,000, but 1,000.5 or something. And now you have one more decimal sign, so you have like 10 times that amount of guesses you have to do.
Because you need to go 101.1, 101.2, 101.3. So they added one extra variable.
Yeah.
Yeah, one extra decimal. Yeah.
So then it always is balanced because
Then it's not 1,000. It's 10,000 more guesses.
I guess so. Yeah, I don't know.
Yeah, because each step will need 10 decimals or 9 decimals, or 1.0 until 9. That's 10 steps.
Yeah,
and for each one,
it's like by 10 times more guesses you will have to do.
Yeah, because before it was 1,000, now it's 10,000.
Yeah. So that.
Yeah.
Yeah,
it's a factor 10 exactly.
Yeah.
So.
But then, like the real cryptographic puzzles in blockchain is a little bit different. Like, yeah, but it's maybe too complicated to talk about. It's like
we can leave it at that, because then at least we have some general idea of what's going on, and from there, so we have now we understand how the transaction is possible with the cryptocurrency and having it decentralized, and also people mining because they want to they're incentivized to to do the work, or let their computers do the work, and able to get some reward, reap some reward from it.
And your cost is the computer or electricity, and if that cost gets higher over what you get back, you will stop mining. Yeah. And then the competition goes down, and the electricity requirements for the whole process goes down.
And then it restarts.
And then it restarts again. So then there is a balance in between those two numbers.
Yeah. So you cannot just. But basically you could just invest a lot of money in it, and you would always be on top.
Yeah.
But I think okay. So we have some, because I read something about like Elon Musk and someone else doing some super computer, just like for this kind of work, or like NFTs or whatever it is to because then we get into the next part. So now we understand how the transaction, basically the bank transferal of money between you and me, how that works in a very easy sense. And from there we get to the NFTs, or not even the NFTs, because NFTs are just products that can be bought through this technology, but the NFTs itself is a technology, or uses the blockchain technology, where you have some kind of identifier, identifying way of saying that. For example, this picture, Mona Lisa itself is an original, and everyone could do like a copy of the Mona Lisa, but it would still be a copy, would not be the original one. The original one would have a value much higher than the copies. And that's basically, I think, the thought process behind NFTs. So in the internet, you can always copy paste a picture. You can always like have a copy of something, but you can never, but you don't usually own the rights for that picture. And before, that was never interesting, and never really like something that you have to think about. And for most people, it's still nothing that you need to think about, because why would you need the original if you can have a lot of copies? But the thing is that you cannot use it because you don't have the rights to use it. So whenever you would use something in the internet, you would have basically to pay the one who owns the NFT able to use it. So that's just one implication of it.
That's just one implication.
And then there is another thing, like NFTs can also like be products, and digital products. So for example, because we see a lot of in the marketplace for NFTs, you can see a lot of art. Especially art, a lot now is really booming in the NFT market, where people do like drawings or pictures or digital paintings or whatever, and then they sell them as NFTs instead of as a service or a product.
So first, let me talk about what the NFT is actually. So when we talked about the cryptocurrencies, which is one application of blockchain, NFT would be another one. Cryptocurrencies are, like as you talked about, fungible, non-fungible. Like the dollar, you can change into dollar. So cryptocurrencies are fungible tokens. Like you can take one ether and change it with another one, and nobody cares. But then non-fungible tokens are these like art pieces or something. And the idea there is that the underlying idea is that you somewhere need to store the state. So we need to know how much ether you have and how much ether I have in my wallet. And NFT is nothing different than we just also store information. So in my wallet, there's not only 5 ether, but there's one Mona Lisa and one cool car or something.
Yeah.
Or like a motorbike picture and stuff like that.
Or a digital card picture.
Yeah. I meant digital assets in all of those cases.
Yeah.
So you would still, if I want to sell this Mona Lisa to you, we still need Carl over there to do the transaction for us. So that layer stays the same. It's just that what you need to be more specific which token you hold. Instead of just saying 2 ethers, you need to say one token is this Mona Lisa, one token is this car or something.
Yeah.
So that's the NFT. And then the issue with the NFT, or the issue I see, is that the originality comes from the original issuer of it. Like, if you're an artist, you draw something and then you say, this is the original, this is the NFT that's going to represent the item, then that's fine. But the example you put it in the beginning, when there was this Joe Rogan clip and some third party took this clip, then it's just that person saying this is the original, but somebody else can take the very same clip and say this is the original, and you still have the same problem.
So one of them, and then how would you check that one of them is really the original?
No, it's like let's say you have a CryptoKitties is one first of the NFT examples. It's like you would buy these kitties online.
Kitties?
Yeah, it's
like a cat.
Like a cat, and then you
but a real cat.
No, it was like a digital art, but it was a game as well. You could like breed them, and they would create a third one.
Like a Tamagotchi.
Yeah, but they got super expensive as well.
Yeah.
And there was nothing really, stopping anybody else to create their own version of this game with their own, animals or whatever. But it's just the brand of the CryptoKitties made you think this is the original. This is what I want.
So it's basically like with companies, right?
Yeah.
So you build a company, and you sell some kind of product, which is original in the beginning. But then if you don't secure it with like a patent or some other security which identifies yours as the original, then someone else can just come and do the same and do their version of it and say that's the original.
Yeah. But what's becoming more and more cool about NFTs is that it doesn't need to be only to track who's the owner. It can have added features. So let's say some influencers, somebody has like I'm an artist, I create a song, and then I put NFT about it, and then I say whoever owns this NFT will get 20% of my income of that song.
Yeah.
And that all can be like written in the code in the NFT logic itself. So then whoever, the group that handles these payments from like radio station stuff, they wouldn't pay directly to the owner, to the author, but they would pay to this NFT, and the NFT would take 20%, pay to the current owner, and pay 80% to the original artist.
Yeah.
So with NFTs you can have
like stocks.
Yeah, like stocks.
So you basically buy a stock in their product.
Yeah.
Like a part of their product.
But you can be much more sophisticated than what stock can do currently. And you can also say, every time somebody sells this item to somebody else, I still get a cut as original owner.
Yeah, that's interesting.
So yeah, you could code it in
really
very different ways.
So you can basically build your own business around NFTs the way you want to sell the products. And as long as you find something which is of value or which some people will be interested in transferring, especially if you build some NFT which the customer or the buyer will always end up selling by some arrangement that, okay, whenever you sell this, you will get an added bonus of 5% of the original value, or something like that. But then you also can say that whenever this is sold, I will get 10% of the current value.
Yeah.
So they will always get a little bit more, so they will always want to sell it, so they want to buy and sell, buy and sell, buy and sell. And through that cycle, you can get your money.
Yeah.
And you're not doing any work. You're
Yeah.
just putting it out, and then you're good, and you can put next one, next one, next one, next one.
So you could code, as what you said, basically, you could code that the next selling price needs to be at least 5% higher than the previous one, always.
So would it be easy to do your own NFT? Like to if you just have something digitally or just some function or whatever it might be, if you want to sell it as an NFT, is it easy to just convert it?
Yeah. So there are a bunch of platforms online that you can use, like marketplaces, and they have...
They're like Blocket in Sweden.
Yeah. I think OpenSea is one of them.
Yeah.
And then you kind of upload your picture and you use their smart contract, because smart contract is what we call the algorithm, the logic behind the NFT. Like when we talked about, the original author gets 5%, that would be coded in such a thing called smart contract.
Yeah.
And that smart contract also lives on the blockchain, so it lives in these blocks that Carl is transferring. So Carl would not only like transfer the thing, but he would transfer it by running this code. So he would run the smart contract we've written.
Yeah.
And that would meant that 20% goes to you and 50 to somebody else.
Yeah.
But you can use these platforms already. How that works is that they take cut from every sale, I think.
Yeah, it's like Fedora or whatever. They will do it for you, but they will get a percentage of each transaction.
But I think they might be doing, I'm not sure, but it might be that they get percentage of every sale, so not just the first one.
Yeah.
But then even if
so they do this thing that I was saying.
Yeah.
But they're not producing the NFTs themselves.
Yeah.
So they're basically saying, okay, so whatever thing that has been sold on our marketplace at one time will always reap us profit whenever it's sold.
Yeah.
That's amazing.
Yeah, but
That's
the
amazing,
service
man.
they provide is that you don't need to hire a coder to write you the smart contract.
Yeah.
Because they've already written like very general smart contract, and then they use them on all the NFTs.
Yeah, but I mean that's the easy part, right?
Yeah.
Because they've just done some general things that, and no one will probably never ask for something else than the options that are in the marketplace, right? So the way to make a marketplace more interesting than the one that is there would be to maybe to give more algorithms, more possibilities, or possibility to write your own algorithm on demand.
Sure. Yeah, I mean,
is there something like that today?
I don't think
you
so.
know?
Like they already have several options, and you can choose more, I guess. But then you get on the other side of the spectrum where it's no longer worth it for them to, write a custom smart contract for you.
Yeah.
Because there are different cases. Like when I was playing with this technology a little bit, I used a test network where you don't like pay for anything. But basically I created this NFT, and when you buy this, you can change a sentence on my website, and then it has some custom code to do this, and then my website is looking at the state of this contract to kind of figure out what it should show. So you can add a bunch of, and it doesn't have to be like my website. It could be like a billboard next to the street.
Yeah.
And then you own the billboard, but you can sell it to somebody, and then somebody else can change what the billboard says.
Yeah. Yeah, that's interesting.
But then you have like more advanced or more like custom logic you need to write into it.
Yeah, because then we get into more like expanded through what can be like a possible future thing that some people are seeing, which is basically not doing this for art or doing this for like some card or some picture, but actually doing it for like real estate or actually owning land.
Yeah.
So basically there is this, as an example, there is this homepage, I think World 2.0 or something.
Yeah.
I'm not sure exactly what the name is, but it's basically what they have done is they have taken like a virtual copy of the world.
Yeah.
And they have said that now you can buy with cryptocurrency or with regular money.
Yeah.
You can buy your own spot in the digital world.
Yeah.
And their hope is basically that in the future, when this is more interesting and this is more, this has spread more, then everyone will want to have their own piece of land in the digital world.
Yeah. Well, I've heard
and
about...
I mean, that connects. And now we're getting into the mumbo jumbo part of like everything, where we're talking about the matrix and we're talking about going from just having virtual reality, which before was crazy and now is really normal, into augmented reality, which is half magic, half technology. And then we go into the place where basically we create a simulation of our own world, where we can live a separate life or own separate assets inside of that. Even though it's just code, if people are willing to buy the code, it has value. It's just like a Pokemon card. It's just a card, it's just paper.
Absolutely.
Has no value at all, but if people want it, then they will pay money for it.
There is the thing that somebody else can come in 2 years and create Word 3.0. And then whatever you had in Word 2.0 doesn't translate to Word 3.0, right?
Yeah.
But there are some other projects that do like something what you described, but in a real life. Like even now, if you sell or buy a house, you need this attorney to like secure the money transfer. You send money to some safekeeping, and then the person transfers the house to you, and then they send the money to the person selling the house.
Yeah.
But you could do that with smart contracts, and some people are doing that. And then it needs to be that, you know, this registry of who owns what, which is maintained by government usually, or some government agency. They need to kind of integrate with this technology. But if they do, then you no longer need attorney. You just send money to this contract, and the other person like agrees or does the transfer of the money, and at that point the money will go to the seller.
So then basically you could do a contract where whenever someone is selling a house that you have owned at some time, you can get money off of it.
Yeah, you could do that.
Sounds like an interesting deal in my head.
You will need to find very interesting buyers for that, though.
However, I mean, people don't even read contracts nowadays. If it would be a smart contract, like they would be, okay, sure, let's go. And they don't care, because whenever they sell it, I mean, it's not their, I mean, they don't care if you get money from the next customer or the next one after that. Because they're already sold with their profit. They already got what they wanted, basically. And you can, what you could do is you could say, we jump over the first step, right? So whenever I sell it, so when they sell it the first time to a new customer, like customer 2 then. So I sell my house to customer A. Customer A sells to customer B. From B to C, that's where the contract starts kicking in. Like where the tick starts ticking in, like a fee. Because maybe if you sell it to A, they will understand that when they sell it to B, they will lose money from your smart contract. But if you just jump over the first step and say no, it will not start until after you sold your house. They're like, yeah, okay, I don't care. As long as I get my money, and we can start the smart contract, and then it will only go, because the property will still have to be sold. I mean, it will still roll around. Then, of course,
the guy B would wonder, right? Like, the C guy paid that much, and I got 5% less. Where the rest of the money is?
Yeah, but I mean, the house that he bought is still bound to the contract. It's just the way the contract is. That's what you bought. You just didn't realize it.
Okay. That would work.
Yeah, but then again, selling a house is not something you do like every year.
Yeah.
So maybe you would want to have the thing as an art instead, where the money part is less valuable. So it's okay if you lose 5% on each transaction, because really it doesn't matter. It's not that much money, and you have a lot of transactions.
Yeah, and then there are also a lot of like cons to cryptocurrency and smart contracts.
Yeah.
One of them is that because of the nature how everything is like unchangeable, because you would have to break the chain to change stuff, even the smart contract itself is unchangeable. So if somebody finds a loophole in it, you can't fix it. Like, it's gonna be there forever. So
a good business would be to find loopholes in contracts.
Yeah, there are some hackers that do that.
Yeah.
And it's even
you
no
that's
difficult work, but you could even argue that
but usually I mean
that it's not illegal, because
it's not illegal.
They're just using the contract how it's written.
Yeah, of course. It's like like normal contracts.
Yeah.
It's like you didn't think about this when you wrote the contract. Okay, then tough luck, man.
Yeah.
So the logical part of it shouldn't be too hard to understand where the because I mean the contract, even though it's smart contract and it's coding, it should still be it needs to be easy to understand. I mean, written out in some way, like
well, you use programming language to write it.
Yeah, you use programming language to write it.
So you already limit how many people will be able to like read it well. Or
yeah, but okay, so that's a problem, because if normal people would like to use like smart contracts, they would have to be able to understand all the conditions in the contract.
Yeah.
And then you would have to like translate it to like that would be a good business idea.
Translate the smart contract?
Yeah.
Yeah, sure.
Yeah, just add it as a bonus. So whenever like to whatever sites uses smart contracts or whatever transactions, we can go into the coding, understand what is happening, and write like a proper contract.
But then you probably would take the responsibility of being correct.
No. No, it's their responsibility to read it, the copy with the original. To like.
Oh, so it would be just notes to help you explain the concept.
Yeah. Like yeah, exactly. So it would be this is basically what it is. But if you really want to understand everything, you need to read this, because you would have to do that either way. But here is like the overall.
Okay. Yeah.
That's what I'm thinking. But maybe as you say, maybe there is no big value in that. You would probably have to be more precise and really.
Yeah. So what the smart contracts are now, they are really simple, because of this limitation, or because of these limitations. Like, people don't understand them.
But isn't there a way to do complex contracts?
No, because the thing with the language, the human language, is that it's not exact. Like.
Yeah, I know.
We have many constructs that don't mean exact things.
Like lagom mycket, or maybe it's inom rimlig tid, or like whatever.
Non-ethically, or like you do something which is not ethical.
Which is
how do you measure that?
Yeah. It's not really defined.
Yeah.
It's just depending on who reads it.
Yeah. If the language would be explicit, we would use language to talk to computers, but because it's not,
we use coding.
Because coding is just language that is just more specific.
Do you think that computers ever will be coded or
give an instruction via like verbal speech?
Yeah, no. If they are ever coded into a place where they can understand and value normal speech,
well, I guess they're already doing it, right? Alexa or these computers,
robots,
they can hear you, and they can parse your speech and understand your intent, what you meant, and they will do that.
Yeah, because that's really interesting. I had a now we go to a way different thing, but I had like a film idea.
Okay.
An idea of like starting off with a guy, a youngster sitting by his computer, and programming his baby AI.
Okay.
Yeah. And just like just a communicational thing, like someone who hasn't any friends or whatever, and he starts to live together with this robot or with this chatbot or whatever it would be, and then he because he programs it as an AI, and then it gets smarter and smarter, and then afterwards he transfers it into maybe like a small robot which can move in X and Y axis.
Yeah.
And then from there it gets more sophisticated by the years, and as he lives and he gets older, this computer and this robot gets smarter
Yeah.
and gets more human
Yeah.
through the interaction with him and
Mhm.
interaction with the world and
Mhm.
understanding him and whatever. So over time this evolves basically from like the first code, hello, how are you, good, how are you, what are you doing, I don't understand.
Mhm.
You know, from that stage all the way to like actually understanding human feelings, being able to process them, and basically becoming human.
Yeah.
In the mind, in the thought, in the train of reasoning
Yeah.
and emotional reasoning, and from there
Mhm.
understands how fucked up the world is
Yeah. Okay.
and how hard and complex everything is, and gets depressed
Okay.
and tries to commit suicide
Mhm.
because of how complex and hard and emotional and everything is,
All right.
but survives, sees the positive things in life, and starts to loop in that direction, and then in some way will like live happily ever after, or just like shuts down with a happy smile.
Yeah.
So that's a like a nice, that would be like a nice
message. Or
nice message. So
Yeah.
so the thing, it can get depressed after the owner dies,
yeah.
and it has gotten as emotionally proficient
Yeah.
as to understand exactly how that feels, and really gets depressed and wants to do the same, because there's no reason in life
Yeah.
after this owner has died, but then maybe realizes that the owner has a child or something, and
Yeah.
from there, you know, swings
Right, right.
back and starts to see all the beautiful things in life from the basics and up, and this one turns out to teach the child about life.
Yeah.
That would be an amazing film, I think.
Yeah. I can't wait to see it.
Yeah, we'll see. I just have to do the podcast first.
Yeah.
Should we wrap this up?
Yeah.
That
I
was
guess so.
amazing,
Yeah.
right?
Yeah. It was fun.
You were a bit nervous, but you went hard.
Oh, yeah. I'm afraid it was too technical in some parts, but
But it's okay.
yeah.
I mean, that's why we're here, right?
Yeah.
Because otherwise I would have to read about it.
Yeah.
And reading about something is way harder than just reasoning about something
Yeah.
and going back and forth. So I thank you for the knowledge, man.
No problem.
Nice. We will cut the computer and just hope that it's not really bad and that nothing has died.